This video briefly describes how to use Matlab in order to plot a function. And in this video, what we'll be doing is plotting the function y equals x squared over the interval from 0 to 1. So the way that Matlab works in terms of plotting is kind of in the way that you may have plotted functions in high school. In high school, you would have created a table of values labeled one column x, the other column y, and then plotted the pairs of points x, y. Matlab takes on the same perspectives. So for example, let's say that I wanted to use just 2 points to try and plot the parabola y equals x squared, which of course is going to be silly, but let's try it anyways. The 2 points I'm going to use are 1 and 2. Now this colon operator in Matlab says to create a sequence with the first input as its starting value and the second as its closing one. So here I just created a sequence 1, 2, incremented by 1. So in order to compute the corresponding y values, I need to square the x values, and in Matlab we can do this with the operation x dot root 2. Now what does this dot do? Well, what the dot does is it tells Matlab to take this vector x, which contains the entries 1, 2, and to square each entry. If I don't put the dot, I'll receive an error, and we'll talk more at some later point about when this operation will be appropriate. But for now, most of the things you'll be doing will just be using the dot operation. So I lied earlier. I said we're going to plot this function from 0 to 1, yet I'm using points 1 to 2, so we will plot this function from 1 to 2 instead. Now, the plot function in Matlab is super easy to remember because it's just plot. And since I've defined a vector of inputs and a vector of outputs, plot xy will give me a blue line between those 2 points that I defined. Obviously it doesn't look like a parabola, but remember we already said that what we were doing was silly. This is just to get used to the plotting functionality. All right. Now within the plot editor, there are ways to do this from the command window, but if you want to get started, you can easily edit properties of a graph using figure properties, axis properties. For example, you can add labels on the axes, or you can change the color of the line and stuff like that. But we won't get into that too much for this activity. What we will do is describe how we can get a more accurate graph of the function. Well, a more accurate graph could be obtained if we choose more values for x. So what we're going to do is we're going to define a new sequence. We're still going to start at 1, but now we're going to increment by 0.1 until we get to 2. So if I do not use the semicolon, which I will not for now, we can see that what this does is it creates a vector whose first entry is 1, then 1.1, 1.2, so on. And you may recall from a previous video that if I use the semicolon operator, it still defines x but suppresses the output. Right. So now I can still define y in the same way. Y is x squared. And now if I plot x comma y, we get a slightly prettier parabola, and we could make it look prettier by choosing an increment of 0.01, for example, instead.